In this video, we're going to look at a past paper question involving hyperbolic functions. We're going to look at manipulating hyperbolic functions and solving equations, including hyperbolic functions. So let's go, first of all, part A. We have to rewrite 5 sin x plus cosh x in a sort of exponential form. Well, in order to do this question, you have to know the exponential forms of sin and cosh. Well, sin x is the same as half e to the x minus e to the minus x. And cosh x is half e to the x plus e to the minus x. Great. So now in our equation we have 5 sin x plus cosh x. Well, this is fairly straightforward. 5 sin x plus cosh x is just 5 lots of the first one, so 5 over 2 e to the x minus e to the minus x plus cosh x, which is just half e to the x plus e to the minus x. Now we're going to expand the brackets. We get 5 over 2 e to the x minus 5 over 2 e to the minus x plus half e to the x plus half e to the minus x. And then we collect like terms. So how many e to the x's do we have? We have 5 over 2 plus a half, so we get 3 e to the x. And how many e to the minus x do we have? A half minus 5 over 2 is minus 2 e to the minus x. So that's the first question solved. I'll just write the answer up here. 3 to the e to the x minus 2 e to the minus x. Okay, let's look at part B then, which is a bit trickier. Let's just get rid of this. So in part B, we notice that the form of part B is pretty similar to part A. We've got this 5 sin x plus cosh x part in our question. So to solve this equation, 5 sin x plus cosh x plus 5 equals 0. Well, we're just going to use the answer from the first part. So this is the same as solving 3 e to the x minus 2 e to the minus x plus 5 equals 0. Okay. Now this looks quite tricky. It's an equation involving e to the x. And the trick with these, and often in hyperbolic questions, is to multiply everything through by e to the x. So if I multiply everything by e to the x, I get 3 e to the 2x. And then I get plus, I'm going to move the plus 5 in front, plus 5 e to the x minus 2 e to the minus x times e to the x just gives 1. So I just get minus 2 equals 0. And the reason I sort of switch the order around to bring this 5 in front is because now this is a quadratic equation in e to the x. So, you know, if we let y equals e to the x, then our equation is 3y squared plus 5y minus 2 equals 0, because e to the x squared is e to the 2x. Now this is quadratic, so we can solve it. We get 3y and y, and we get I think y plus 2 here, y minus 1 equals 0. Okay, so this has two solutions. 3y equals 1 or y equals minus 2. Well, that implies 3 e to the x equals 1 or e to the x equals minus 2. Well, e to the x is always a positive number, so at least when x is real, so this is impossible. So we can ignore that solution. So we just need to look at the solution 3 e to the x equals 1. So to look at that, I get e to the x is 1/3, so x is, just taking the logs of both sides, x is log 1/3. So that's my only solution. X is the log of 1/3, which is in the correct form as desired by the question.